In this video, we will discuss quartiles and percentiles. When comparing data, we will often define benchmarks for making comparisons. The most common of these benchmarks are quartiles and percentiles. Quartiles are boundaries that divide the data set into 4 parts. 3 boundaries are needed. To divide a data set into quartiles, first find the median of the data set. This divides the data into 2 halves. Second, find the median of each half of the data. Third, the median of the lower half of the data is the boundary for the lower quartile. The median of the upper half of the data is the boundary for the upper quartile. And of course, the median of the whole data set is the boundary of the middle quartiles. For example, find the quartiles for the set below. This is, in fact, the same set that we were dealing with in the previous video, and we will continue to deal with this set for a while. Since the data are already in numeric order, the first step is to find the median. There are 25 data in the set, so the 13th is the median. The median is 84. We find the median for the lower half. There are 12 data in this set, so the median will be the mean of the 6th and 7th, which are 76 and 77. The median is 76.5. Then we find the median for the upper half. Again, there are 12 data, and the 6th and 7th are 90 and 91, so the median is 90.5. Then the lower quartile includes anything below 76.5. The second quartile contains anything between 76.5 and 84. The third quartile contains anything between 84 and 90.5, and the upper quartile contains anything above 90.5. The second and third quartiles are called the inner quartiles. The mid-range is not a very good statistic because it is easily affected by outliers. Looking only at the inner quartiles, we eliminate the outliers. The inner quartile range is the difference between the upper quartile boundary and the lower quartile boundary. It can be a useful statistic. To find the inner quartile range, first arrange the data in ascending order. Then find the boundary for the lower quartile and find the boundary for the upper quartile. Then finally, find the difference between the upper quartile boundary and the lower quartile boundary. The inner quartile range is equal to the upper quartile boundary minus the lower quartile boundary. For example, find the inner quartile range from the previous example. We saw that the lower quartile boundary in the last problem was 76.5, and the upper quartile boundary was 90.5. The inner quartile range is 90.5 minus 76.5, which is 14. Percentiles are boundaries that determine a data item below which a certain percent of the data will fall. Relating quartiles and percentiles, the first quartile boundary is the 25th percentile, the second quartile boundary is the 50th percentile, and the third quartile boundary is the 75th percentile. The percentile rank of a data item is the percent of data items that is less than or equal to the given data item. To find a specified percentile, first arrange the data in ascending order, then assign each data item an ordinal number that corresponds to each data point. The lowest data item will correspond to the first ordinal number. Third, find the ordinal number n that corresponds to the given percentile rank by using the formula corresponding ordinal number equals number of ordered values divided by 100 times the percentile rank, or n equals capital N divided by 100 times p. If the result is not a whole number, round up. Finally, find the data item that corresponds to the ordinal number found in step 3. Example, using the data set below, already in order, which is the same data set we've been using all along, find the following percentiles: 25%, 80%, and 90%. So we start by calculating n equals 25 divided by 100 times 25, which is 6.25, and we'll round that up to 7. The 7th score is 77. 25% of the scores are at or below 77. Second, we want to find the 80th percentile, so that's 25 over 100 times 80, which is 20. The 20th score is 91. 80% of the scores are at or below 91. Finally, we want to find the 90th percentile. That's n equals 25 divided by 100 times 90, or 22.5, and we'll round that up to 23. The 23rd score is 93, so 90% of the scores are at or below 93.